Let us look at some polynomials here. We have a polynomial in x which is 2x cube minus 3x square plus 5. Then we have a polynomial in y which is 5y. Then we have x square minus 4 and 3x square y cube minus 5xy plus 7. Now, if you look at these polynomials, can we tell what would be their degrees? Let us recall degree. Degree of a polynomial is the largest part of its variable terms. So, in this case, since the largest part is 3, the degree would be 3. Over here, the largest part is 1, so the degree is 1. In this case, the degree is 2. And for this one, since we have two variables, the degree would be sum of exponents of both of these variables, which is 2 plus 3, that is 5. Now, in all of these, we either had one variable, 1, 1, 1, or two variables. But can we have a polynomial with no variable? For example, can we have something like this? Fx is equal to 5. Does this classify as a polynomial? And if it does, what would be its degree? Let us look into it. Let us rewrite fx is equal to 5. Now, we can just write this as 5 into x raised to power 0, because we know that x raised to power 0 is 1. So, this is actually 5 into 1, which is 5. Also, this does classify as a polynomial. It fulfills the criteria of being a polynomial. It has a whole number as its power and there is a coefficient, a real coefficient. So, this is clearly a polynomial. Also, since this is just a constant, we call it a constant polynomial. So, we can say that a constant polynomial is a polynomial with no variable terms. Also, if we have to talk about its degree, let's again rewrite it as 5 into x raised to power 0. The highest power is 0. So, the degree of a constant polynomial is 0. And now, what if we have a polynomial where all the coefficients are 0? For example, this one. Now, again, this does classify as a polynomial, right? Because it fulfills the criteria. But it just simplifies to px is equal to 0, right? And this is called a zero polynomial. So, we can say a zero polynomial is a polynomial where all the coefficients are 0. Now, the question is, what would be its degree? Actually, the degree of a zero polynomial is undefined. Now, you must be thinking, how can degree be undefined? And what does this undefined mean? Let us look into it. Let us rewrite the zero polynomial. Now, think about this. Can we write it as 0 into x raised to power 1 plus 0? We can. And if we look at this form, we will see that the degree is 1. We can also write it as 0x squared plus 0x plus 0. But in this case, the degree would be 2. We can keep on doing this. We can write it in the form of a cubic polynomial like this, and over here the degree would be 3. So we realize that there is no specific degree. Right? For a zero polynomial, there is no specific degree, and that is why we say that the degree of a zero polynomial is undefined. Let us move on to classification of polynomials according to their degrees. Let us draw a table which has degree of polynomial, its corresponding type, along with an example. Now, let us fill in all that we know by now. We know that a zero polynomial has a degree which is undefined or not defined. For example, px is equal to 0. Then, if a polynomial has a degree 0, it is a constant polynomial. For example, px is equal to 2 or px is equal to minus 7. Now, if the polynomial has a degree 1, we call it a linear polynomial. For example, x minus 12 minus 7x plus 5. Here the highest power is 1, so its degree is 1 and it is called a linear polynomial. Similarly, if the degree is 2, we call it a quadratic polynomial. Here are the examples: x square plus x minus 6, x square minus 5. Similarly, for a degree 3, we call it a cubic polynomial. And we have an example: x cube plus 2x minus 8. Now, for higher degrees, for example 5, 6 or 10 or 100, we usually write it as a polynomial of degree n is called nth degree polynomial. Let's say there is a polynomial in which the highest power is 7. So, we'll call it a 7th degree polynomial.